So what happens if you want to do better at solving quadratic equations than completing the square maybe 500,000 times? And the answer is you complete the square once on some general equation where a, b, and c are variables instead of numbers. And then once you're done completing the square once, you use the results ever after, and those results are called the quadratic formula, and I would like to show you an example of doing that. So we are going to first of all divide everything by a. Both sides of the equation by a, that gives us x squared. No, x squared is pitiful. The pen here is actually doing very poorly. Something's wrong with my pen. Plus b over a x plus c over a equals 0. And then we're going to take away c over a from both sides. I'm going to bring it over here to the left. And now we're getting ready to complete the square. The way we complete the square is we take a look at this coefficient and we cut it in half, or divide it by 2, or multiply it by a half. And then we multiply that by itself. That was our pattern. So that'll be b squared over 4a squared. So we're going to add b squared over 4a squared to both sides. On the right-hand side, we're going to need a common denominator for our subtraction, and so it looks like we need to multiply the top and the bottom of this second fraction on the right by 4a. That'll give us 4a squared there, so we're going to have a common denominator of 4a squared, and on the top we're going to have b squared minus 4 times a times c. On the left-hand side, hopefully we made this be a perfect square, so we're going to factor it. Factoring this looks horrible, but it's not, because we know where this came from. It came from b over 2a times b over 2a. So we have x plus, I'll move this up a little bit, b over 2a squared equals, and then we have this mess over here, and we're going to take the square root of both sides, and then we're going to remember the plus or minus. We have x plus b over 2a equals plus or minus the square root of b squared minus 4ac on top, and the square root of 4a squared on the bottom. That is still b squared minus 4ac on the top, but the square root of 4a squared, that's 2a. So now we're going to subtract. I'll scroll up a little bit. We're going to subtract b over 2a from both sides. This then is the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, where all these a, b's, and c's are simply these coefficients. So you get 0 on one side, and you can read off a, b, and c, and you can plug and chug. And now let's do some examples of that. We use the quadratic formula. Well, we get 0 on one side, and then we strip off the coefficients. A is the coefficient of the squared term. Here it's an understood 1. B is the coefficient of the x term. It's a 2. C is the number. It's a -4. And so now we're going to use that quadratic formula. And the quadratic formula in this case, we're solving for x, as x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Instead of plugging it in per se, I kind of read it to myself as I do the work. So here we go. X equals the opposite of b. b is 2, so the opposite of b is negative 2, plus or minus the square root of b times itself. b times itself, 2 times 2 is 4. And then the way I read this is minus 4 times, and then I put in parentheses whatever a times c is. a times c is negative 4. All divided by whatever 2 times a is. a is 1, so 2 times 1 is 2. So we have x equals negative 2 plus or minus the square root of 4, and then a negative 4 times a negative 4 is a 16. And so, scrolling up a little bit, we have x equals negative 2 plus or minus the square root of 20, all divided by 2. However, the square root of 20's prime factorization is 4 times 5, or 2 times 2 times 5. So the square root of 20 is the square root of 2 times the square root of 2 times 5. That's 2 times the square root of 5. So we have x equals negative 2 plus or minus 2 times the square root of 5 divided by 2. This 2 can be distributed underneath each part. And we have x equals negative 1 plus or minus the square root of 5. And we're done. So let's do this problem. I'm going to get 0 on one side by subtracting 6t from both sides. And then I'm going to assign my values. A is 1. There's an understood 1 there. B is negative 6. C is 10. And then x equals, or actually t this time, I'm solving for t. T equals the opposite of what b is. That's 6. Plus or minus b squared, that's 36, minus 4 times a times c, that's minus 10, all over 2 times a. A is 1, 2 times 1 is 2. And so I have t equals 6 plus or minus, this is 36, take away 40, so that's the square root of negative 4 all over 2. That's 6 plus or minus the square root of 4i all over 2. That is 6 plus or minus 2i all over 2. The 2 can be distributed underneath each part. And so we have t equals 6 over 2 plus or minus 2i over 2. T equals 3 plus or minus I, and we're done. Those are our two solutions to this equation. Let's try this problem. So we have 0 on one side already, so we have a equals 6, b equals negative 1, c equals negative 2. We're solving for x. X equals the opposite of what b is, plus or minus the square root of b squared. B times itself is 1, minus 4 times whatever a times c is, and that's negative 12. 6 times negative 2 is negative 12. All divided by 2 times 6, 2a, which is 12. And so we have x equals 1 plus or minus. This is 1 plus 48, that's 49, so it's the square root of 49 over 12. That is 1 plus or minus 7 over 12. Now, when the square roots disappear like this, when this is a perfect square, we actually got to calculate both answers, so there's a little more work here. X could be 1 plus 7 over 12, or x could be 1 minus 7 over 12. So here we have x equals 8 over 12. Divide top and bottom by 4, that'll be 2 over 3, so x equals 2/3. That's one of our solutions to this original equation. And then we have or x equals 1 take away 7, that's negative 6 over 12. And that's negative 1/2 if you divide top and bottom by positive 6. So we have these two solutions, 2/3 and -1/2. Both of them would work there. If we put in, for instance, 2/3 here and here, it would check. Just for the heck of it, I'm going to check. You don't have to. So the question is, does this equal 0? And 6 and 3 cancel to 1 and 2. So we've got 8/3 here. Take away 2/3, take away 2 is supposed to be 0. 8/3 take away 2/3 is 6/3, take away 2 is supposed to be 0. 6/3 is 2. 2 take away 2 is supposed to be 0. Check. So 2/3 would check if you did this work, and so would -1/2, and we're done.